Okay, today we will learn about Born-Haber cycle. First of all, we need to know what is actually Born-Haber cycle. It is known as an energy cycle. However, when you want to measure lattice energy, we cannot measure it directly, but we have to build a Born-Haber cycle first. So, lattice energy can be obtained indirectly by applying Hess law in Born-Haber cycle. Standard enthalpy of atomization is the energy absorbed when 1 mole of a substance is turned into 1 mole of gaseous atom under standard conditions. Standard enthalpy of ionization, the energy absorbed when 1 mole of gaseous atom are ionized under standard conditions. Standard bond enthalpy is the energy absorbed when 1 mole of particular bond is broken or formed. Electron affinity is the energy absorbed when the 1 mole of a negative ion is formed from 1 mole of the gaseous atoms. Lattice enthalpy or lattice energy is the energy released when 1 mole of ionic substance formed from gaseous ion under standard condition. Standard enthalpy of formation is the energy released when 1 mole of substance is formed from its element as the axis at STP. After we learn about so many definitions, now we proceed to the example. By referring to the data below, construct an energy level diagram, or better known as Born-Haber cycle, and calculate the lattice energy of sodium chloride. We can see that sodium chloride lattice energy equation have been given. Then we have ionization energy, atomization, electron affinity, and enthalpy of formation. The first step when we want to draw the Born-Haber cycle is to start with standard enthalpy of formation. Then we proceed with standard enthalpy of atomization. We can observe from here that sodium which is in solid state have been changed to sodium in gaseous state. As for chlorine, Cl2 is in molecule. Therefore, we have to change it into Cl gases, which is the atom. Now we continue the cycle with standard enthalpy of ionization for Na and electron affinity for Cl. We can see that sodium gas in gaseous state have been changed to Na+, and for Cl have been changed to Cl-. Lastly, we end our Born-Haber cycle with lattice energy, which is Na plus Cl minus. We will be forming back NaCl solid. After we draw the Born-Haber cycle, now we can use Hess law to calculate the lattice energy. By using Hess law, H1, H2, H3, H4 plus lattice energy is equal to enthalpy formation of NaCl. So at the conclusion, we can get the lattice energy, which is negative 795.7 kJ per mole.